Hello everyone, welcome back to the Hyperledger Composer development series. In this video, we're going to be talking about the Hyperledger Composer /Fabric modeling language, which is found in our perishable.cto file. So in the last video, we were looking at this business network completely finished. I had taken you through a short demo of how to execute transactions, create participants, assets, etc., etc. Now we're going to dig into the code and see just how one might go about building this very business network. Now, when we start to look at the model file, it's a little bit intimidating because there's a lot of terms that, aren't necessarily intuitive enough to just understand from a development perspective. That being said, if you have done any development in the past, this shouldn't be too hard to grasp. I'm going to go ahead and take us through how to build this very business network from the ground up, and hopefully the way that I do it will reduce any confusion that you might have just looking at this model file. So what I've done is I still have all the files for this business network that we saw in the last video, but what I've done is deleted all of the definitions that were in the permissions file, the models file, and the scripts file. This is just a placeholder function so that we can build our .bna binary that we'll upload to the playground over here. I think the best way to start this out is to just get something uploaded into the playground, just because it's a great visual tool to see what we're doing. So I'm going to put together a very, very basic model file right here. So I'll talk about all of this a little bit more as we go, but we're going to say that the namespace, which is it inherently applies to every resource definition within this model file. We're just going to name this org.quickship, that'll be like our company, QuickShip. So once we have a namespace defined, we can create a resource. So we can say participant grower identified by name. Then we're going to come in here and say string name and string email. Something really basic like this. Don't worry about all the syntax yet. I'm going to walk you through all this, but this is just a very basic business network that we can visualize in the playground now. In order to do so, we have to build it. And you can see that I'm in the perishable network directory. And what I'm going to do is I actually have two options. I'll take you through the most efficient way right now, which is to type composer archive create. We'll define our source type and our source name. And we'll say we're creating this in the dist directory, replacing our previous perishable network.bna. And we can see that the command has succeeded. Now, the other way that you can do this, which actually is a little bit, it takes a little bit longer, but it's a lot shorter to type, we could just do npm install. You can see that this produced the same exact result. Now, the reason I say that this is a little bit more inefficient is all we wanted to do was create a new BNA file, and what we ended up doing was running through the entire startup script that is defined in the package.json. So we're going through the pre-published, pre-test, lint, blah, blah, blah. It just takes a little bit longer. So I would definitely recommend sticking to the composer archive create command. But now that we've done this, let's go over to our Hyperledger Composer. I've actually got two tabs open for the sake of this demo. But we're going to import that BNA file that we just created. you can see we have perishable network.bna. We can open that up and import it. Okay, so we can go over to the model file, and you can look down here. It says everything looks good. This means that our business network is syntactically correct and should work. And you can see a very simple model file. If we go over to the test, you can see that we have just one participant, the grower, and what we can do is create a new participant. We'll call this participant Joe. Joe@email.com. And you can see that we've created a new participant. We should probably extend this model file into a larger network because right now it's pretty useless. Before I go into doing that, I want to explain the basics of the modeling language, which I will suggest looking at the documentation. If you come to the Hyperledger Composer documentation, you can go down to the reference section and click on modeling language, which details a lot more than I can in this video. But anyways, I'll give you the basics. So within our CTO file, our .cto file, there are a couple essential components. One is a single namespace. Two are resource definitions. Now, you've already seen both of these, but let's go into a little bit more detail. Let's go back to our perishable.cto model file. You can see these are the two essential elements of the file. This is the bare bones definition of what we need. The namespace at the top, I've named arbitrarily org.quickship, as in organization, and then quickship is our company. Now, obviously you can do whatever you would like with this, and you'll see how this plays out later in the video. Next we have the resource definitions. This right here, the participant grower, is a very basic example of a resource definition. But there are many, many more definitions that we can use. So let's start with our class definitions. These are the backbone of this model file. And they include assets, transactions, and participants. Take you back real quick. This is an example of a participant class resource definition. So these are the class definitions. We'll go into those in a second. But let's also see what we have left. So we have events, an enumerated resource definition, and concepts. As we build our business network, you'll see how all of these resource definitions kind of look and play together in a symbiotic relationship. Like with any database, or model schema, there's obviously going to be some data types. So you can see that I've only used the string data type for this participant in the network, but there are a lot more that we can use. I've defined these right here, so I'd suggest you maybe pause the video and just take a quick glance at them, but they'll be popping up throughout the video. As you can see in the network that we're trying to build, there are three main participants: the grower, importer, and shipper. I think this is a good place to start to kind of get familiar with the modeling language. You can already see that I've done a sample participant, but this is not what we want for the ultimate end goal of this business network. So what we're going to do is start defining these three participants as defined in the final business network. So how they're set up is like so. And before we get into this, let's just take a moment to understand the syntax of the model file. So the first item you must define is the type of resource definition, which is participant. Then you give a name to it, and then the identified by, and then email, is essentially like in any database with a primary key. The identified by email is saying, okay, we're going to identify the grower participant with the primary key of email. So we can say string email, and now this is our primary key. I'll also note that this little symbol here is simply an O on the keyboard. A little bit different from most languages, but I guess that'll do. So we've got our string email, which is the primary key for the participant grower. Then we're going to add in a double data type and call it account balance. This is the basic definition of the grower, but we need other participants. So let's say participant, let's importer and shipper. So importer identified by email, and we'll say string email double account balance, and finally we'll say shipper. As you can see, this is getting pretty repetitive, and I would hate to do this every time I have to define something that's so similar. Luckily, this model specification allows us to do just that. Instead of defining a separate participant for each different name, what we can do is create, as we talked about here, a concept, which is going to allow us to kind of almost build a template and then transfer that over to each participant. Now, in order to make our lives easier, all we have to do is put abstract before our participant definition. So we'll say abstract participant business. This is how they defined it in the sample network. Identified by email, just like we did below. And now what we can do is copy this same definition up into an abstract class. Now, this business participant can't actually be created, and you can see this over here under our finished network. The participants are the grower, importer, and shipper. You don't see business anywhere under that label. So any abstract class cannot actually be created, but is more so a model for subsequent participants. So in order to make the grower, the importer, and the shipper inherit these definitions, all we have to do is say participant grower extends business. And now every time we create a grower, we're going to have to put in an email and account balance. So let's do that for the remaining two. All right, so now we've created 3 participants in the network that inherit these definitions. So let's go over and just test this out for a second. So we want to create a new grower. So we'll say create participant. And as you can see, we have a class of our namespace, which, might I add, is a little bit different from what we have defined. But we have the namespace dot grower, and then we have an email and an account balance down here. Now, to extend this example, you can obviously see that we're missing something. We're missing this address, which almost looks like some sort of dictionary within this grower class. So in order to create that, we're going to take a similar concept to an abstract class, and we'll say a concept. We'll call this address. So in defining this, we'll say we have a string city, country, street, and finally the zip code. Now, in this definition over here, you can see, all I see is a country right here. Now, that's because it's not showing the optional properties. So let's click Show Optional Properties, and you can see we have everything defined in this concept of address. In order to create optional fields, all we have to do is type optional, after the field. And at this point, we can now add the address concept. As you can see here, address, and then we'll name that address. So now, every time we create a new grower, importer, or shipper, we need to enter the email. We're going to need to enter at least the country, and we can optionally enter the city, street, and zip code for this address concept, and then finally the account balance. So right about now, it is time that we can iterate and test this business network again. So what I've done is actually create a script file called createbna.sh, and you can see that all I've done in that script file, using the cat command just to print out the contents of the file, is this command that we went over previously, the composer archive create. It just gets tedious to type this every time we have a new iteration of the business network. So I'm going to go ahead and execute that script. And we can see that our business network has been updated. Now, to visualize this, and again, like I really suggest using the Composer Playground for visually testing and seeing how your code is working. It's just a great way to do so, because all you have to do is come and upload the perishable network BNA, just like we've done in the past. We can look at the model file and see that everything looks exactly like what we have here in our local environment. Now let's go and test this really quickly, and we'll create a new importer. And as you can see now, we have exactly what we expected, and let's go ahead and click optional properties. So I'm going to create a shipper, and that, or an importer, and that's going to be me. We'll just go with a Miami. I do not live in Miami, but country USA, street, beach, side, lane, and the zip, whatever that is for Miami. And I'll give myself a healthy $1 million in my account. You can see that we've successfully created the importer Zach with the ID zach@email.com. Remember, we created this participant and say it's identified by email, and so that is officially the ID for this participant. And then again, we can go to the transactions and see that this was basically uploaded to the blockchain. So before we get any further, let's take a look back at the models text file that I created, just to highlight the fact that all we've created thus far is 3 participants. We haven't added any assets or transactions yet, and that's where it starts to get really interesting. So what we're going to do next is create an asset, and it's going to go like this. We will say asset as the identifier, just like we said participant down here. We'll say asset because this is just another class resource or class definition, and we'll name this asset a contract because it's going to be a contract between the grower, shipper, and importer. We will say identified by, and we'll go with a contract ID. So expanding this out, we'll say a string for contract ID. And just a quick note, it's kind of one of the quirks of this language. I haven't looked into it far enough to explain it fully, but for an ID, unlike most database schemas, we're using a string rather than like an integer or something. So that's just kind of something you have to go with. Furthermore, we're going to introduce one more concept to this whole modeling language, and that's the relationships. So, with any relational database, you obviously have relationships, and you can do this here as well. Now, there are a few things to note. One being that the relationships are unidirectional, meaning they're only going one way. You can't have bilateral relationships in the composer modeling language. Also, we can note that when you delete something that has a relationship, the delete does not cascade down along the chain of relationships like some relational databases might do. In order to create a relationship, we use this syntax, a dash dash and a caret. And that's basically saying we are relating to, and then we'll put in a grower, because we're going to relate this to our participant grower, and we'll call this grower. Now, to illustrate this, I've pulled up the full network again and created a few objects. This is, once again, this is not what we have created. This is the end goal of what we will eventually have created. But if you look at the grower here, or I apologize, if you look at the contract, you can see that we have grower, as we specified here, grower, and it points to a resource in the namespace that we've defined with the grower object and then a hashtag and then the ID, or the identified by field. So you can see how that relationship kind of works. And we're going to do this with all of the participants in the network. And now, as you see, we have all the participants in the network identified by their respective objects. And then to finish this off, we just have a bunch of extra information. We have a date time that marks the date of the transaction. We'll call this arrival date time. We have a double, which is the price. Another double. If you remember from the last video that I did, I kind of explained how this contract worked. But essentially, you have a minimum and a maximum temperature that the perishable goods can be shipped at. And if they're outside of those temperature bounds, there is a price penalty, as we're creating right now. And there we go. That should create our first and actually only, well, I believe it's our only, okay, so we have a shipment and a contract asset. So this is one of two assets that we're going to create. We're going to create our last asset here in this part of the video, and it's going to take us through the remaining ideas and concepts behind this modeling language. So if we go back to our definitions, we've already created concepts, and then we've created participants and assets. Things we have not created are transactions, events, and this thing called enumerated. We won't do transactions and events until the next video because it's kind of out of the scope of the modeling language. We're going to have to get into some of the JavaScript logic. But what we can do is look at the enumerated type, and you'll see how this plays out in just a second. So we'll create our next asset, and we'll call this our shipment. We'll identify it by the ID, shipment ID. and you'll see me type in here something called product type, which clearly looks like an object, but we haven't created it yet. Autocomplete does not seem to like me today. Okay, so let's go ahead and create that. We'll go below this asset to do so. And this is actually an enum called product type. And how the enum works is if you have something that is only a finite number of options, for example, in our perishables network, there's only 5 different products that we might be shipping. So this is a perfect case for an enum. So how we do this is just define the different possible products. Okay, so you can see we have an enum that represents the 5 possible products that we have. And while we're at it, we'll create another enum saying our shipment status. Our shipment can only be in one of 3 states: created, in transit, or arrived. We're going to use these 2 enums in the shipment asset. So we've already got the product type, and we're going to say our shipment status as status. And then we will say we'll put a long in there, unit count, and then we'll put a relationship to the contract. So within this shipment, this last relationship line is just basically identifying which contract this shipment pertains to, because we can have multiple shipments and multiple contracts. We need to be able to keep track of that. Now, one thing I am leaving out that we will have to get back to is called temperature reading. And this is another class definition, and it represents a transaction, but we will not be getting into that because that'll just be in the scope of the next video. But anyways, this is how it might look like. And coming over to our network, you can see that what I just added was this temperature readings, which is optional, and essentially it's saying that on a particular shipment, we may or may not have had a temperature reading to date. So it's optional in the case that, you know, a shipment does not need to have a temperature reading, but once we submit that transaction, we come down here to the bottom left corner and submit a temperature reading, and we're going to submit it to our ship 001, and we'll say 3 degrees Celsius. Now what you can see is this shipment here, ship 001, has updated to represent another temperature reading. And that was all executed within the JavaScript logic, the smart contract that we will eventually get into. But for this video, we've covered pretty much everything that you need to know in regards to the modeling language, minus the transactions and events that we'll be covering in the next video. So stay tuned for that, and I hope that you learned a lot through this tutorial. Thanks.